Problem number 4 is asking for an example of different types of angle relationships. The first one, 4a, is asking for adjacent angles. Adjacent angles share a ray or a side. So if they're just out, they're not in a figure, they're not in a shape like this. These are adjacent angles. They share this this ray. If they're in a figure like a pentagon, for example, then adjacent angles would be like this angle is next to this angle. They share this side length. Those are two examples of adjacent angles. Vertical angles are formed by intersecting lines, and they're the angles that are opposite each other. So these two angles are opposite, they're congruent, and they're called vertical angles. Complementary angles are two angles that add up to 90 degrees. You could show them as adjacent angles within a 90 degree angle. I'll show you what I mean. You could start by drawing a right angle, and then you can just do this. So I have this angle and this angle must be complementary because they form this right angle. Or you could have them, you could just sketch them outside of a figure and label them. Maybe this one's 30 degrees and this one's 60 degrees. Supplementary angles add up to 180 degrees. So I'm going to start with a straight line and then just draw two adjacent angles that are forming that straight line. And so they must be supplementary because this one plus this one have to add up to 180 if they're forming this straight line, this half circle. An acute angle is an angle that's less than 90 degrees. So any angle under 90 degrees, and a reflex angle is greater than 180 but less than 360. So you have to draw it, but then you also have to make the arc mark for sure on this one, because otherwise someone would think that you're talking about this angle. So this is an example of a reflex angle. Problem number 5 has several parts. The first part is asking us to describe the transformation of triangle ABC that resulted in the image A prime, B prime, C prime. So ABC is up here in the first quadrant. A prime, B prime, C prime is down here to the left and down in the second and third quadrants, and so it's been translated to the left and down. But in order to say how much, we have to pick a vertex. I'll pick vertex A and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left to get there. So it's been translated. Because a translation, remember, is like a slide. 10 left. And from there we go 1, 2, 3, 4, 5, 6 down. So that describes the transformation. It's a translation, 10 left and 6 down. If you reflect triangle ABC across the x-axis, so let's first highlight the x-axis. If you having trouble with this writing tablet, sorry. We translate triangle ABC across the x-axis. What will be the coordinates of the reflected triangle A double prime, B double prime, C double prime? We need the double primes here to distinguish between this image that we already have on our coordinate plane, A prime, B prime, C prime. So I'm going to start with the vertices that are closest to the x-axis. C and B are both 2 above the x-axis. So when we reflect, remember, a reflection is like a flip, FL, like a flip. When we flip the vertices over the x-axis, C is 2 above, so it will now be 2 below. C double prime will be. B is 2 above the x-axis, now will be 2 below the x-axis, B double prime. A is 8 above the x-axis, so it will be 1, 2, 3, 4, 5, 6, 7, 8 below, A double prime. and we can connect those with line segments. And the coordinates would be a double prime is now positive 6x, negative 8y, so 6, negative 8. B double prime is 6, negative 2. And C double prime is 2, negative 2. The last question asks, what do you call the point located at the intersection of the x and y axes? This point is called the origin. Problem 6, we're asked to calculate the area of the figure. We have a composite figure. It's composed of a rectangle and a triangle. I imagine there are other ways to break it up, but that seems like the most logical, probably most efficient way. Assuming we can get dimensions of that for triangle, we'll try that in a minute. Write your formulas and show your units for your final solution. So the rectangle, I'll call that shape 1, is very straightforward. Base times height. I can get the base directly here. It's 20 meters. The height is also shown, 6 meters. So the area of that large rectangle is 120 square meters. The area of shape 2, we need the triangle formula, 1/2 multiplied by the base multiplied by the height. The base is this blue distance, this line segment. I know that this is 8, and I know that this is 6, and I know that this entire distance across is 20. So if I do 20 minus 8 plus 6, 20 minus 14, that will give me this distance, which is 6. So the area of my triangle is 1/2 multiplied by the base of the triangle, which is 6. The height of the triangle, oh, for a second there I didn't think I could get it, but I forgot. This is given as 10, this entire distance, and this is 6. So the distance just from here to here must be 4. 10 minus 6. So the height is 4. So the area of the triangle is half of 6 is 3, and 3 times 4 is 12. The total area will equal area 1 plus area 2. So 120 plus 12, 132 meters squared. Okay, that completes page 2. We'll continue the review with page 3 on the next video.